For our project, we worked with Logic Broker to create a system that would help them to manage data related to products, as well as to reprice products based on several different algorithms. Logic Broker provides technology to help unite retailers, brands, and the system they rely on. As far as the Logic Broker API, we needed their product feed, required fields, and the ability to upload corrected fields. In order to get access to this data, Charlie and I studied and tested the Logic Broker API using a software called Postman. Postman allows users to send handcrafted HTTP requests and observe the response that comes back. Using this, we were then able to move into actually writing code that did the same thing. I began implementing functions in Python that could send and receive data to and from the API. The first function accepted parameters, built a GET request that downloaded data. The second function was similar, except that it uploaded new data to the API via a POST request. The Python JSON and request libraries were used for interacting with the API. At this point, the data being returned would be parsed and entered into the data structure Charlie implemented.
Our repricing engine features 3 functions the user can choose to run. There is a market average function that outputs the average of the retail prices found. Also, there is a price below market function that outputs a price a certain percentage determined by user input below the lowest price found. Additionally, there is a price above cost function that outputs a price a certain percentage above the cost to manufacture a product. Again, the percentage used is determined by user input. Because the manufacturing cost of products is not readily available, we simulate the cost as 1/2 of the market average price based on keystone markup rules that are commonly used in retail. All functions also have a user input of a price they would not like to go lower than, called the lower bound. If the result of a function is lower than this, the price will automatically be set to the lower bound.
One of the largest parts of this project was the acquisition of missing data in the Logic Broker database. Products that are missing data attributes in the Logic Broker system are labeled non-compliant. To transform each of the non-compliant products to compliant, we leveraged existing shopping platforms eBay, Amazon, and Walmart as the main data resources for this task. There are 2 methods used to extract data from these platforms: the leveraging of web scraping for the utilization of enterprise APIs, as well as web scraping. Web scraping is the process of extracting large amounts of data from websites by traversing through the website's source code. As long as the structure of the website pages remain consistent, web scraping algorithms will have continued success. For this part of the project, our team decided to leverage Python's free and open source web scraping framework called Scrapy. With Scrapy, we can create high-performing spiders with which define how platforms such as Amazon and Walmart will be scraped asynchronously. We chose to leverage Scrapy rather than other web crawling frameworks such as Beautiful Soup and Selenium due to its customization features, its ability to work with large sets of data, and its scalability.
We've all encountered several challenges during this project. One of the key challenges related to our system was issues related to web crawling. Not every website is going to have the products we are looking for or all of the necessary data to make a product compliant. We combined data from 3 different platforms to resolve this issue. We also had to make our bots undetectable from website security features, such as by identifying user agents or rotating our IP address. A possible solution we discussed with Logic Broker for this was to use each site's commerce APIs. However, both Amazon and Walmart were unable to provide us with keys to access their API. Our team member, David, however, was successful at integrating an e-commerce API into our system.
Due to the low standard for product information required by the eBay commerce platform to display on their website, eBay is very lenient with granting access to their APIs. After creating an eBay developer account, I acquired an API key to call the eBay Finding API, which allowed me to acquire the same amount of information that is readily available through crawling their site. The advantage of using the API was that I would get information much more reliably than with web crawling, unless the product we were searching for was not even being sold on eBay in the first place. With the information coming back much more consistently from the API, we were able to integrate that information with the information gathered from the web crawlers with no conflicts. Moving forward, this product could be expanded to include even more e-commerce websites, and upon deployment would help Logic Broker to provide their customers with competitive pricing in an oversaturated market.